Good morning, everybody. As we know, tomorrow morning we will do our midterm examination and come early. Okay, the exam will start at 8:30, but you should be ready by 8:15 so that your groups are set up fine and you can test your setup, everything. So don't be late. After we started showing the questions, we will not accept any latecomers. And I think you have read the instructions for the exam. Read it very carefully. If you have any questions, just send me email. If you have any concerns, just send me email or the TA's email, and we will try to find a solution for you. Okay, if there are no questions about the midterm exam instructions, then I will continue my discussion with polymorphism and virtual functions.
Sir, you said instruction has you need to use just one sheet of paper, but I solved a few questions and one sheet of paper is not enough to solve all problems.
How did you see that? Did you see the questions?
I see question last year questions.
So I was wondering that because I didn't prepare the questions yet.
I solved the last year questions.
But this is not last year, okay? This is different. We are doing an online exam. If you think that I am asking the same question as last year, you are mistaken. Okay, any other questions? One sheet of paper should be enough for each question, and we are going to divide question into different parts, and you should be fine. Unless you write very, very large, in that case it's your problem. And for a normal handwriting, one sheet of paper should be enough for each question. Okay. So let's start today's lecture. Polymorphism and virtual functions. I think we started talking about it yesterday, and this is the basic introduction actually. Polymorphism means, what I am going to say in this slide will not make much sense, but it will talk about generic coding, okay? Generic coding, or again code reuse. You are going to write certain amount of code which will be very, very generic. That code will be usable by many other, will be used in many other places, and polymorphism makes this possible with the help of the inheritance. So the main idea of polymorphism is you have a function, okay, you have a one function name, but you associate many meanings to it. So that function name behaves differently depending on the context, depending on the situation. During the runtime, this decision is made for you by your automatically produced code, okay? And the virtual functions are the main tools to achieve this, okay? To associate many meanings to a function. And it's a fundamental principle of object-oriented programming. It's not an invention of C++, okay? So all the object-oriented programming languages know about this polymorphism, and in fact it is one of the fundamentals of object-oriented programming, as we said, okay? So the virtual functions are maybe not definition, but one of the main features of virtual functions is this. Virtual functions can be used before they are defined. It is very interesting. I mean, before you define and implement it, you are calling it and it works, okay? When you associate other meanings to this function, your code will continue working again. No problem. Yesterday I started talking about one hierarchy, shape hierarchy, remember. Let's continue that one. Let's continue the shape hierarchy. Okay, so we said that we have a class shape. Let's say this is our shape.h file. I am not going to use includes or guard directives just to save some space and be faster. Okay, class shape in my public section. Okay, shape is a two-dimensional shape. That's it. Okay, in my public section, of course, I have my constructor, and I'm going to. Okay, let's try to implement this here. Although I don't know what to put in there, I will just keep this open. Okay, I will just keep this open, and we will see what I'm going to put in there. I will have a function named returning double, which will return the area of the shape. Of course, it's a const, and it will return the area. And let's say I have another double, it will return the perimeter of the shape. Of course, it's a constant again. And let me write another one, a boolean, okay, and is larger. This boolean function will take another shape object, okay, and of course it's a constant. Let me implement this in this small space actually, and I will say return this dot area larger than other dot area. Okay, so I have implemented it. So that's it. A very simple class. It returns the area of the shape, perimeter of the shape is larger, takes another shape object as a reference, and it returns a boolean. If my area is larger than the other shape's area, then I will return true. Otherwise, it is false. Okay, and for my private section, I don't have anything to write. I cannot, because I mean, if this is a circle, I mean, instead of a shape, if this is a circle, I would said I have a radius, right? I don't have a radius. If this is a square, I would say I have an edge. If it's a triangle, I would say the base and the height. I mean, I don't know. I mean, if it's a ellipse, I would say I have two radiuses. Okay, so for my private section, I don't have anything to write. So what am I gonna do? I will just do this. Okay, can I save this and load this again, because this is doing some funny stuff. I don't know why it's doing it. I like to reload this. Okay, did I open this more than once? Okay. I guess this is it, right? Okay, good. So my private section will be empty because I don't know what to put in there. It's just empty. So let's try to implement these functions one by one. Constructor doesn't do anything because I don't have any private members. Nothing to initialize. Area, how do you calculate the area of a shape if you don't know anything about the shape? So what am I gonna do? I think just to, I don't know, I think I am going to do this something like return. Let me try to make this more curly. Okay, return -1, so that people would know that doesn't make any sense, because when you ask the area of a shape, then you will get this answer -1. -1 cannot be an area, -1 cannot be a perimeter, so it shouldn't make any sense for the caller. They would know, otherwise my program would not compile. Okay, so this is whole shape class, and I didn't need a I didn't need any implementation files. I have implemented everything in my header file. Okay, so this is my shape.h. So what kind of code is this? I don't know, but I think my intention is this. My intention is to write to form an hierarchy. This is my shape class, and I will derive other classes such as a circle and maybe a rectangle. Maybe from rectangle I will derive a what? Can you tell me what can I derive from a rectangle?
Square.
Yes. Is this correct? Think about, is a relationship. Should I put square here or there? I mean, should I switch the positions of rectangle and square, or this is fine? Am I doing it right?
Actually, a square is a special rectangle, so it doesn't necessary.
Let's look at this is a relationship. Circle is a shape, right? We know that. Rectangle is a shape too. Is square a rectangle? Yes, right?
Yes.
But are all rectangles squares? No, right? So square is a rectangle, but not all rectangles are squares. Not all shapes are rectangles, but all rectangles are shapes. So this is right, and this is right, and this is right. Right? Okay. So this is a good hierarchy. I did not write this hierarchy. I did not write it yet. But still, I can maybe this was not a good idea to write it that way. Let me do it. Let me write the shape .cpp. Okay, shape.cpp. Let me implement it in a way that, okay, of course I will include my shape.h, and I will do this. a Boolean shape is larger. Okay, so, and get rid of this one. Okay, so, and if I like, I can in my, let me put my console in here. If I like, of course, I can compile g++ -c shape.cpp. Would this work? Would this compile? Would this compile? I'm just compiling a shape.cpp. Let's look at this shape.cpp. Would this compile? Would I get any syntax errors, compilation errors? Come on, it's a simple question. I'm just asking you to compile this. I could have asked this question last month. I did not say anything new yet.
Sir, I think no, because already included shape.he.
I have already included what? I have included shape.h, and I am implementing this is larger here. So why this would not compile? What error message would you get?
I think this is a pointer.
Which one is pointer?
Return this area.
Yeah.
It's concatenated with arrow, not dot.
Oh, you mean like that? Okay, yeah, that's a good. Okay, let's fix that one. This arrow. Okay, how about this now? This area greater than O dot area. Would this compile now?
Yes.
It should compile, no problem. It should compile, no problem, right? Okay, it should compile and no problem. Okay, so, but the thing is this: when I compile this, okay, shape.h or shape.cpp do not know anything about who is going to drive what. Okay, they don't know about this hierarchy. Okay, they don't know this about this hierarchy at all. Okay, they just I wrote this simple line and I compile them. So how does the compiler know which function to call? Okay, my intention here is later in my driver code, let's say I am writing driver1.cpp. What I am saying is, okay, include shape.h, and in my main function, okay, in my way, this is going to be very late after I have written them. In my main function, I will have two shape objects. Let's say one of them is a circle C1 with radius of 1.0, The other one is going to be a rectangle R1 with two sides 10 and 20, and I will just do this maybe. C out C1 dot is larger R1. Okay, I will just do this. I can call this function is larger, but is larger here doesn't know anything about the area functions. Area functions are not defined in this function, right? In this class, because they are all -1. That doesn't make sense. And I am calling this function with now two different class types. One of them is a circle, one of them is a rectangle. Okay, but this code doesn't know anything about that yet, because those classes is not created when I have compiled this code. Okay, when I have compiled this code, of course, I need to include here, include circle.h, and I need to include rectangle.h. In order to compile driver1.cpp, of course, I need the definition of circle and rectangle, but for the shape, for this is larger function, I don't need them. Let's go back to this slide and let's try to remember what we said before. We said that these functions, these virtual functions, they can be used before they are defined. This is what we are doing here, okay? This is what we are doing here, okay? In this case, I am trying to use those functions before I have defined them, before I inherited them and I override them. The term is going to be the overriding. I override them. Before I override them, I am using them, okay? So that means that this is a very generic code. This code, once written, can be used by many other classes, and this code will not know anything about these new classes. All it knows is that the area and perimeter will be defined on those functions. Let's go ahead and let's implement some of those classes. Make this a little bit smaller so that it can fit in my space. Okay, so let me do this here. Okay, so let's write the code for the circle.h. Of course, include shape.h, and the class is going to be very, very simple. Class circle, I derive it from public shape, okay, and public constructor. Circle, it takes a double R, default value is 1.0. Let's use this notation, and in the implementation I don't have anything, okay, and let's define this double area, and it is of course const. It will return a meaningful thing now. Return, let's say I have a constant pi which is defined in math.h. Okay, I did not include it, but okay, pi times r times r and I have the perimeter. Again, it is const return 2 times pi times r, and I am not going to do anything else. So I have redefined these two, I have overridden these two functions, and in my private part I have a double r. Okay, it looks like I have implemented everything in this header file. Just to make a circle.cpp, I will have include shape.h. That's it. My circle.cpp is this, because I have implemented everything in the header file. Okay, so this is the picture now. I can now compile G++ minus C circle.cpp, and then I can compile, of course, my driver1.cpp and G++ minus O, my executable, what, shape.o, circle.o, and driver1.o. So that will compile everything. So I am coming back to this one. As I said before, when I compiled this code did not know anything about this area function, how it is implemented for circle or rectangle. Okay, and suppose I have the rectangle.h, and rectangle.h is doing the same thing, and rectangle.cpp, of course. Okay, so both of them are here. Okay, so I implemented them in a similar way. Here, I have written a base shape class. It didn't know how to implement area and perimeter, so it did not. But it knows how to implement is larger. It knows how to implement this function named is larger. Okay, without knowing what kind of area functions will be called by this function. That's called polymorphism, because, as I said before, polymorphism is based on these virtual functions, and those virtual functions can be used before they are defined. So what makes a function virtual? Actually, this code will not, when I run this code, you know what is going to happen? It will call this area and o.area. They will call the function of the shape class area and perimeter, if I have called perimeter. If I do it this way, they will not call the area of circle or rectangle. Why? Because this is fixed during the compile time. The compiler says that, okay, shape, I know shape class, it is here. Area of shape is here, it returns -1, and this one is going to return -1. And even though here I am calling is larger with circle and rectangle, this function says that I am going to call the area function, and the area function is here, it is -1. I will return -1. Okay, it is because these functions are not virtual. If I make them virtual, let me write this virtual keyword. It's a C++ keyword, virtual, and this one is virtual too. Okay, you are telling the compiler that these two functions are special. Why are they special? They are special because if you are calling these functions like this, you need to wait until the runtime, not compile time, but runtime. You will make a decision on which area to call during the runtime. Okay? So for now, up to now, we have been using non-virtual functions. Everything that we have compiled, everything that we have written, they were all non-virtual functions, and their meanings were fixed. Okay? Their meanings were fixed. Okay? We did not use them before they are defined. We define them and we use them up to now. But now, when you do these functions as virtual, okay, when you define these functions as virtual, the compiler knows that with this kind of code, this area or O dot area, okay, the compiler will wait. Okay, compiler will not produce the code. Compiler doesn't know which area it is going to call. Okay, the compiler says that I will wait until the runtime. If somebody calls is larger during the runtime, it will come to this position and it will look at the object. What is this shape? Okay, I will call this is larger with this C1. C1 is a circle. Okay, so this is a circle. Then I will call the circles area. And here O is a rectangle. So I will call rectangles area. So it makes this decision during the runtime. So that's what the virtual functions are. And that's what the polymorphism is. What was the meaning of polymorphism again? Can somebody tell me the meaning of the word meaning of polymorphism? What is the word meaning of polymorphism? Can somebody tell me? We talked about this yesterday. Poly means many. Somebody said something, but I did not hear it. I am waiting. I am waiting. Okay, let's go to the class list. My class list doesn't work either. I think there is a problem with my connection. Okay, so can somebody tell me what the word meaning of polymorphism is? Either in Turkish or in English. I cannot view the class list.
Poly means many. Morphism means shape, like shape shifting.
Okay, so poly means many and morph means shape or face or in Turkish maybe çeşit, çok çeşitlilik, çok biçimlilik. Okay, so why do we keep saying the same thing? Because the compiler doesn't know the face of this area, okay? It doesn't know the type of this area. It just as a function, but it is not implemented yet. I don't know its definition. I will make that decision during the runtime. How am I going to do that? Okay, somebody is going to pass me a shape, and I am a shape too, but I don't know what kind of shape I am. I could be this shape, or I could be this shape, or this shape, or this shape, or maybe later somebody is going to derive another one, maybe later, much later, I don't know when. Somebody is going to derive another one, and it is going to be maybe a polygon. Okay, it's going to be a polygon maybe. Okay, so it doesn't know. So during the runtime I will make this decision. That's what makes it polymorphism. Okay, to be able to achieve polymorphism in C++, you need these virtual functions. We call them virtual functions because during the runtime they are decided which function to call. If the functions are non-virtual, it is all compiled. It is all decided during the compile time. We call this concept, okay, late binding. Late binding is deciding on which function to call during runtime. And as opposed to early binding, is just the opposite. I mean, decision during compile time. Okay, so we have been doing early binding examples all the time. When we make a compilation, compiler knows exactly which function to call. Okay, compiler knows exactly which function to call. If I erase these two virtual keywords here, okay, these two function calls becomes early binding calls. Okay, these are non-virtual. Compiler knows that area will return -1 and area will return -1, both of them. Compiler will know that, okay? Compiler because knows that area is going to be called of the shape class. Compiler knows this because this is not a virtual function. Area is not a virtual function. But if I put them back, okay, I don't need actually, okay, for the perimeter, since I did not use the perimeter, okay, if I put this virtual back, compiler says that these function calls will be decided later during the runtime. So I will bind them late. They are called late binding. I will bind them late. Okay, so that's the meaning of polymorphism, and that's the meaning of virtual functions. It might seem a little bit detailed stuff, yeah. I mean, it might be maybe useful for some. It might be useful for some rare cases, you might think, but it is not actually. We use this all the time. We use this all the time in many places, especially with the operating systems or the graphical user interfaces libraries. We use polymorphism a lot. There is one common usage with the operating systems. Let's say you are writing a Windows application. Tell me an application, a Windows application, a simple application. Windows operating system application that you are writing. Very simple application. Let me turn up here and let's see. Let's say you are writing a calculator, okay? you will write a class for calculator. Okay, your class calculator. Windows says that if you are gonna write a calculator, if you are gonna write a application like this one, calculator, okay, this is a Windows application, right? This is a Windows application, nice application. If you are gonna write an application like this for Windows, you have to derive your application class, okay, from this class. This is not the exact name, but it's something like this. WinApp. There is a base class named Windows application, WinApp, okay, WinApp, and you will implement a number of functions, and your calculator will be done. Okay, so there is a class called WinApp, and inside, let's try to see what WinApp does. Okay, class WinApp. It's a base class. It is written by Microsoft. Okay, and of course I have my WinApp, my constructor, lots of parameters. Okay, and it has a virtual function close. Okay, virtual, let's say, void close. And maybe, well, how would you close an application? Maybe close all the files, close all the network connections and everything, that kind of stuff. Okay, but exactly I don't know how to close it. Another virtual function, virtual void resize. It will take a new size object. Okay, what kind of other Windows functions that you think of? Virtual minimize or maximize, void minimize. Okay, so lots of them. If you are writing a Windows application calculator, you need to override this close function, resize function, and minimize function. Okay, this close function, resize function, and minimize function. If you provide them, then you become a Windows application. Okay, so far I could have done this without knowing this virtual, but how about this one? This WinApp has a static void close all function that takes a vector of WinApp pointers, and okay, this function, if you call this function WinApp.closeAll, it will close all the applications of your operating system. Before you shut down your computer, the operating system calls this function with this vector. Okay, it keeps a vector of pointers of applications. Okay, and it calls this function. So let's try to implement this function. Okay, the function is something like, okay, void WinApp close all. Let's put a constant in here. Const vector WinApp pointer and all of my apps. So the function is very simple actually. let's do a range for loop. Okay. Let's say when apps, what am I gonna do is app arrow close, and that's it. So Windows people had written this function 20 years ago, okay, and it is part of this base class WinApp, and this function has been working for the last 20 years, and yet this function will work for any kind of application, and this meaning of close will depend on this pointer app. Okay, if that app is a calculator, then the close function of the calculator will be called. Okay, if that app is pointing to Word, then the close function of Word will be called. It changes its meaning during the runtime. That's why we call this polymorphic behavior. It changes its meaning during the runtime. Okay, that's why these all have to be virtual. Why? If they are not virtual, the meaning of this clause is fixed during the compile time 20 years ago. Okay, so that makes the whole thing more dynamic, and this makes this code very generic code. Why generic? Because this is written 20 years ago, and it still works. It still works. I don't have to change anything. I am using the same close-all function for all the applications, all the existing applications, or the applications that are going to be developed by somebody else. Okay, so that's the idea of polymorphism. Do you have any questions?
Sir, I have a question.
Sure.
How can we close the app if we put const in front of the vector, since we can't change the vector?
Well,
How can we close the app?
I am not changing the vector, right? I am calling a function on the pointers included in this vector. I am using the values of those pointers. This vector has a bunch of pointers, right? I follow those pointers, and I call the close function of each of them. I am not changing this vector. Vector stays the same.
Okay, understand. What if I don't want to change any actually Win applications? How can we achieve that? I mean,
you mean you like to call functions on these apps that should not change any applications? That's what you mean?
yes.
And then maybe it shouldn't be a vector of Win apps. Maybe it should be a vector of constant Windows applications. Const Win app. So you need another class maybe. So
Okay.
I mean, it's not const Win app star or Win app star const, something like that.
Okay.
So don't make your pointers constant. Don't make your customers non-constant but constant. Okay. So does the idea of polymorphism make sense? It's used very much, very often, and the idea is virtual functions, and virtual functions work this way. You need to declare them as virtual, and the virtual means that somebody is going to override them. By the way, this is called overriding. Okay. When I implement this, when I implement this area and perimeter, I am overriding. It is not redefinition. If the function area is a virtual function, perimeter is a virtual function, I am overriding these two functions. I am not redefining it. Okay, that's the terminology. So overriding override, redefine are related, They are both parts of inheritance. Okay, they are very similar, but overriding is done only with the virtual functions. Redefinition is done with non-virtual ones. Okay, here some people say it's redefinition, but we call it overriding. I am overriding this area. Okay, I am overriding this area. Usually for the base class, whatever you are going to override doesn't make much sense. Okay, I mean, the returning -1 doesn't make any sense, right? I mean, why did I return -1? Because I didn't know anything else. I mean, maybe I should return a -1. And some people say that just exit -1. Don't let anybody call this one. Exit -1. Something like that. Okay? So, C++ people said that why are we letting anybody to declare functions like this stupid? I mean, don't implement these functions. Nobody's going to call them. Okay, we don't have we are not going to make any shape objects because it doesn't make any sense. So they let us do this. Okay, they let us do this. I am going to do this. Equal sign 0, equal sign 0. Okay, now these are pure virtual functions. I don't have to implement them. You cannot implement them. You are telling the compiler that these two functions will not have implementations. These are pure virtual functions. Okay? So nobody is supposed to call them. I will not implement them. I will not implement them. These are pure virtual. Because area of a shape doesn't make any sense. Perimeter of a shape doesn't make any sense. It makes only sense when you derive a new class and you override these two functions. Okay, with the virtual keyword. So these are pure virtual functions. Once you have a pure virtual function in your shape class, you cannot make object of this shape class anymore. Okay, I cannot say in my main function, if you say shape S1, this will be a compiler error, because shape is not a complete class anymore. You cannot make objects of shape, because when you call s1.area, okay, the compiler will give you the compiler has no way of producing a code for that one, right? So shape s1 will give you a compiler error, because there are pure virtual functions in this class shape. These kind of classes are called abstract classes. Okay, so I introduced just two new C++ syntax mechanisms. One, virtual keyword to make a function virtual, equals 0. Okay, this is not assignment, this is not comparison. Okay, this is to mark a function as a pure virtual function. I am not going to implement it. Okay, an abstract class is a class that has at least one pure virtual function in it. I am not saying virtual, but I am saying pure virtual. Okay, so the abstract class is a class that has at least one pure virtual functions in it. Okay, let's take 10 minutes of break. After the break, we will continue. Merhaba İlhan. Yarınki sınav için ya şimdi bugün benim epeyce bir işim var da karman çorman kafamı toparlayıp da yapabilir miyim bilmiyorum. Asistan arkadaşlara OBS'yle. OBS yani herkes OBS'yi install etmiş olsun. Bugün hemen bunu hatırlatırsan gitmeden install etsinler evlerine. Artı bir de hani 20 kişi var ya 5 çarpı 5 olabiliyor herhalde OBS şeyindeki görüntü. Evet. Hı. Evet. Evet. İnsanlar okusunlar arkadaşlar. Bunların kimlikleri falan kapatıyorlar yani. Okay. So I introduced you the idea of the virtual functions. The virtual functions means that their meanings, which function to call, will be decided during the runtime, not compile time, as opposed to non-virtual functions. And to make a function virtual, of course, you need the hierarchy. At the base class shape, I have my hierarchy here. At the base class shape, I have declared two virtual functions, in this case pure virtual functions. I told the compiler that these two functions will not be implemented, and then I derive from these this function, this class shape. One of them is a circle class, the other one is a rectangle class, and I have overridden these two virtual functions. Now my class circle and my class rectangle are not abstract classes, they are concrete classes. So let me give you this table. I say virtual, the opposite is non-virtual. I said late binding.
Sir, you got to delay.
The delay is good. Delay is the delay is bothering you. Maybe I should write and wait a little bit. Late binding, early binding. Okay, what else? I said, so these are the opposites, virtual and non-virtual, late binding and early binding. These are just opposites. What else did I say? And I said abstract class. And concrete class is just the opposite. Okay. Concrete class is just the opposite. Concrete class, we have been writing concrete classes. Soyut sınıf in Turkish, somut sınıf. Abstract class is soyut sınıf. Concrete class is somut sınıf. Okay, so we have been writing concrete classes all the time throughout the semester. Okay, we have been doing non-virtual functions. We didn't say that. Okay, we have been doing early binding. We have been doing concrete classes. Now, with the introduction of the virtual functions, I have introduced you the idea of late binding. Late binding is making a decision during the runtime which function to call, and I have abstract classes. Abstract class means that you cannot make objects of these types of classes. How do you make a class abstract? You make a class abstract. Okay, you make a class abstract by including at least one pure virtual function in it. Okay, so the idea of abstract class may not sound very logical for you, because what is a good class? Why should I have a class if I am not going to have an object of it like this? like here in this example, I said that you cannot have an object of this class shape. So I don't write these kind of classes to make objects of. I write these kind of classes like shape to make them as base classes for other concrete classes. Okay, so that's the idea of abstract class. Okay, so I guess the whole chapter is going to revolve around these terminologies: virtual, pure virtual, abstract class, concrete class, late binding, early binding. Okay, so know about these. These are not difficult things, and knowing this is important, but how I achieve all of this stuff in C++ makes it practical. We need to learn about that too. So let's go write some code and let's see how we use these in real life. I got some code from some other source, from another book, textbook, very old one, but old one, but it's a good example, and the example is familiar for us. Okay, let me find that code. Where is the code? Okay, it has a nice table first. Maybe I should do it this way. İlhan sen evde misin, burada mısın? Sen bağlı mısın? Ya, yani bir girmeye çalışsana, ben giremiyorum ya. Bağlanamıyorum. Şu anki toplantı. Zaten bir dakika bağlandı, tamam. Okay. Okay, everybody. Do you hear me now? Can you hear me?
Yes, sir. Yes, sir.
I think there was a problem with my connection. I don't know what it was. Okay. So okay. Much vision, cannot get the sound. Many phase. Hoca dondu mu? Okay. So let's go back to our slides, and this is the slides. Okay. This is oh, let me check my OBS actually. Maybe if OBS doesn't work. Yeah, I should change this to this one. Okay. Turn on my okay. This should be fine now. I read my closed caption text. Good. Okay, so the example that I am going to give you is very familiar example. I have an employee class, base class. This is an abstract class. I am deriving salaried employee, hourly employee, and commission employee.
We
Yeah.
cannot see your screen.
You don't see my screen because I did not share it yet. Here is the screen. Okay, so this is a very familiar hierarchy. I have my, here I am trying to draw the same thing. I have my employee class, employee. From employee I'm going to derive hourly employee. Okay, and then I am going to derive another one, commission employee, and from commission employee I am going to derive base plus commission employee. Okay, so my employee class will be an abstract class because I don't know the earnings of the employee. I don't know how much the employee makes because I don't know what kind of employee it is. And my print function for the employee will print the name of the employee and the social security number. Yes.
Sir, your screen black hole minutes clearly. We cannot see shape.
You don't see what? You don't see the shape?
Writing. It comes now.
Okay, it is a little bit late, so I will try to talk a little bit slower. And I will wait after draw the shapes. And it looks like many people are not. It looks like many people are not logged in. I think they are trying to connect. Is Enis here? Enis, are you here? Enis, can you hear me? So you hear me? Okay.
Yes.
Okay. So on my screen, I see you as I am trying to connect with you. So that means that there is something wrong with these status messages too. Okay, so look at this table. With this table, it looks like with the employee class, I will have two virtual functions, earnings and print, and the meaning of those virtual functions will change from class to class. For the salary of the employee, my earnings will be my weekly salary, how much I make for each week, okay? And for hourly employee, my earning will be based on my hours, okay? If it is less than 40 hours, my earnings will be wage times hours. If it is greater than 40, then I am going to get extra for the hours after 40 hours, and my print will be different. Commission employee is different. Commission employee says that how much sales did I do? This much, and I will get a commission out of it. Base plus commission employee says that I am a commission employee, but I will have a base salary too. I will have a base salary too. And it looks like I missed a class here. I missed here a salaried employee. Okay. So let's look at the code for each. Let's look at the code for each. This is my employee class. Can you see it? Is my delay? Can you see this slide? Employee code?
Yes.
Okay.
Yes, we can see.
Okay. Employee class is very simple. It takes the name, last name, and the social security number, and I have the setters and getters for each. Okay. So a very simple class. So I am not going to talk much about it, but I have a pure virtual function earnings. Okay, line 24. Okay. A pure virtual function earnings, this one, and a virtual function print. Earnings is pure virtual because I don't know how to implement it. Print, I can do something. I can print my name, last name, and social security numbers on the screen, no problem. Okay. So did everybody see this slide, 67, slide number 67? You see it, right? I guess you did. Okay, so I am moving on. This is the implementation of the employee.cpp. Not much interesting stuff here. I am setting the first name, last name with the constructor and setters and getters. Okay, setters and getters, no problem. And as far as I am concerned with the virtual functions, this is the implementation of my virtual function. This is not pure virtual, but virtual. Remember, the earnings is pure virtual. There is no implementation for earnings, but for print there is an implementation. And also note that I don't put the virtual keyword. I don't put the virtual keyword here in the implementation. Virtual keyword, if you like, you can put, yeah, but usually we don't put them in the implementation. Okay, so this is our base class, and it's an abstract class, abstract base class. Let's look at the salaried employee. Salaried employee is here. Salaried employee says that I am an employee, and since I am an employee, I will inherit all the features of the employee class, including name, last name, and the earnings. On top of it, I will add this weekly salary and setters and getters for the weekly salary. Also, I will override two virtual functions, earnings and print. Okay, I will override two virtual functions, earnings and print. Good. Okay, let's see the implementations. Constructor is simple enough. Constructor is simple enough. I am calling the base classes constructor. And to set the weekly salary, I use the set weekly salary. Okay. Why I call this set weekly salary? I call it because I like to do this error checking, validity checking. If salary is less than 0, I will set it to 0. Otherwise, it is 0. Otherwise, it is salary. Okay. So this is set salary and get salary getter. No problem. Let's look at the implementations of two virtual functions. Earnings is as simple as getting the weekly salary and returning it. Okay. Look at the print function. Print function calls the base classes print function, employee print. That's what I'm saying, employee print. And then after that, employee print, I will write my weekly salary. So although I am overriding the base classes print, I am still using the base classes print function in my implementation of print function in this file. Okay, good. We did similar stuff previously. So overriding a function and redefining a function is very similar actually in this case in terms of calling the base classes functions. If we continue, let's continue with the hourly employee. Hourly employee as opposed to salaried employee makes his money by the hours. How many hours did I work? How much do I do for each hour? Per hour. Okay. So if you multiply them both and return it as an earnings, that's fine. So I am going to overwrite these two. I am going to overwrite these two virtual functions. Is my delay okay now? If I do this 1, 2, 3, 4, 5, 6, how many seconds do you see as the delay?
We cannot tell.
Yeah, just now.
Okay, so it is more than 20 seconds. Is that correct?
Unfortunately, sir.
Okay. So I will wait even more. So hourly employee is an employee, and it overrides two virtual functions, earnings and print. And I think you are seeing it now, these two. And implementations, let's look at the implementations of them. I will get rid of, I will not talk about the constructor. There is not much interesting going on stuff. There is not much interesting stuff going on with the constructor. I will skip it. But I will show you the earnings and the print function of the hourly employee. And I will wait for 20 seconds so that you see them now. Okay. So the earnings is, if hours is less than 40, I multiply the wage and hours. Otherwise, I will add more time for the overtime. I will add more money for the overtime. Print is very similar to print of the salaried employee. I call the base classes print function, and on top of it, I write my own specialized data. Okay, this is hourly employee. Good. Let's look at this commission employee. Earnings and print again will be overridden. Commission employee makes his or her money by the amount he or she sells. So 2 new data members, gross sales and commission rate. Okay, this is good. Let me move on to the other class, which is base plus commission employee. Base class commission employee is interesting because it derives from commission employee directly. It doesn't derive from the employee directly. Okay, it's a descendant of employee, but it doesn't derive from employee directly. So the base plus commission employee has all the employees, data members, and the functions. Also has all the members of commission employee, plus it has this base salary. Look at the constructor of the base plus commission employee. It has 3 strings: name, last name, and social security number. Then I have 3 doubles. One of them is for the gross sales, one of them is for the commission, and now one of them is for the base salary. If we look at the constructor implementation, we will see it. Okay, I will wait for 20 seconds. This is the implementation of the base plus commission employee. As you see, all I do is I just call the commission employees constructor. I don't care about the employees constructor. Why? Because employees constructor will be called by the commission employees constructor, right? So I don't deal with that, which is nice. Good. Okay. So this is the constructor. Let's look at the overriding stuff of earnings and the print here. Here what I do is I call for the earnings function, I call the commission employees earnings, and I add my base salary to it. That's it. So as you see, this base plus commission employee actually doesn't care about it derives from employee. All it knows about the commission employee. Okay. Commission employee handles everything about being an employee, and then I use this commission employee's earnings function and the print function. And that's it. So this completes all the implementation and the definitions of all the classes. Let's see some example code that uses all these 1, 2, 3, 4, 5 classes, right? 5 classes. I have 5 classes. The employee class is an abstract class, but I have 5 classes. Remember when I said you cannot do this. You cannot say employee E1, E2 with the names Ali, Yilmaz, and 175 something like that. Okay, this is a compiler error. Why? Because employee is a okay, let me wait for 20 seconds. So I cannot write this statement employee E1, E2. I cannot write this statement because employee is an abstract class. That's what we said. This is a compiler error. I cannot write that. Okay, but I can do this. Employee pointer EP. an employee pointer. Let me wait for 20 seconds. You can, of course, do this. A pointer to an employee object. Can anybody tell me what good is this for? Can anybody tell me what good is this for? If I cannot make object of a class, where can I use such a pointer? I use double pointers to point to double objects. I use many pointers to point to many objects. And then where can I use these employee pointers? Because there are no employee objects, right? Can anybody tell me why would I make such pointers?
For make use of polymorphism.
Explain that a little bit. I don't understand what you're saying.
For example, employee object can refer to base class or any other employee that are derived from the employee class, and we can call their functions, virtual functions, according to them.
Yes, exactly. I cannot say EP will get an employee object address, but I could say, let's say I have this hourly employee, HE, some parameters, I don't know, and I could say EP gets the value of address of hourly employee. See, I can say that. This is possible. Because each hourly employee is an employee object. So the employee pointer can point to a hourly employee or salaried employee or commission employee or base plus commission employee. Okay? So this is possible. Okay, good. And I think we had that similar stuff in our previous example. Let me go to our previous example. Remember this class? Remember this class shape? .h. Let me wait for 20 seconds. Okay, so this class shape, it has two pure virtual functions. That's why it's an abstract class. So nobody is going to make a shape object. But how about this is larger function? It is waiting for a shape reference, right? It says that send me a constant shape reference and I will work. But how can I obtain a shape reference? Okay, because there are no shape objects. That doesn't mean that I cannot derive from this shape class, such as circle or rectangle, and use this function with the objects of circle and rectangle, right? So this function is obviously expecting references of circles, rectangles, ellipses, polygons, and etc. That's what this function is waiting for. Okay, let's go back to the other slides again. And let me move on to show you some driver code for these nice 5 classes. Okay, this is our driver code. Look at this slide. It says that I am going to include IO stream. I am going to include IO manipulation stuff for formatting and vector, right? and then it included all the header files of employee, salaried employee, hourly employee, commission employee, and base plus commission employee. I have two functions, line 22 and 23, virtual via pointer and virtual via reference. It will take a constant employee pointer and a constant employee reference. Okay, and we are going to see the implementations of those functions in a minute. Did my delay improve a little bit when I write 1, 2, 3, 4, 5, 6? Did my delay improve a little bit?
Unfortunately, sir.
Okay, so continue speaking slowly in a delayed fashion. So
20 seconds, sir.
20 seconds. Okay, so you've seen the slide then. Let me switch the slide to show you the rest of the driver code. This is my main function. In my main function, I am creating 4 objects: salaried employee, hourly employee, commission employee, and base plus commission employee. I have 5 classes, and I am creating 4 objects of these 5 classes. I cannot make objects of employee class, and I call the print function of each object, line 43, 45, 47, and 49. At the top, I have created 4 objects, and I called the print function of each. Print function is a virtual function. What did we say about the virtual functions? Virtual functions are decided during the runtime. We don't know what print function is going to be called with the virtual functions, and they will be decided during the runtime. That's why we say it late binding. But to use a virtual function like a virtual function, I did not tell you all the conditions. For example, line 43, it is not a virtual function call. It is early binding. Although print is a virtual function, to use a virtual function as a virtual function, you need to meet some conditions. What are those conditions? Conditions are these, okay? If f is a virtual function, okay, to be able to use this as a virtual function, you need to call it either with a pointer to the base class, like this, okay? A pointer to the base class, PTR is a pointer to the base class, or a reference to the base class, ref dot f, okay? PTR pointer to base, and ref is ref to base. That's how you use a virtual function as a virtual function. If you don't call okay, if you don't call a virtual function using either of these 2 ways, you are not going to get late binding. Okay, it looks like people are having even more problems. They are getting my screens after 2 minutes. That's not good. I don't know what's going on. And I think, well, you have your midterm tomorrow. Maybe, okay, I will stop here 2 minutes early. Doesn't make much sense to continue like this. So you concentrate on your midterm, and after next week, I think this will be fixed, or we are going to think about something. Okay. So that's it for today. We will see you tomorrow for the midterm exam.
Sir, will we have time for the right question on paper in midterm?
I gave you the instructions, and if there are extra instructions, you will hear it during the midterm, and that's our plan. Yes, we will let you write the questions on your paper, and after that you will continue answering those questions, and we will go on like that.
Thank you, sir.
Okay, study hard, and we will see you tomorrow.